Unit 6, Lesson 5. Today it's all about operations with one-step equations. Our essential question for this lesson is, how are inverse operations used? So you might have to find out what inverse operations even are before you can answer this. So we'll be looking at as we move through the lesson. At the top, the very first thing we're going to encounter is right over here on the left, and that is the property of equality. Now, it is a property in math, so you can trust it, and it does have the word equal in it. So what does it mean? It's similar to the golden rule. Do unto others as you would have them do unto you. You may have heard that before. Down here, we have a bunch of equal signs, and I'm going to highlight those equal signs all the way down. The first one, we have a plus sign here. And let's say if we're going to add 5 to one side of the equal sign, that means the property of equality says that we have to add 5 to the other side. We have addition sign again. It's not a mistake. It's just saying if we're adding a negative 5 to one side, then we have to keep things equal and also add negative 5 to the other side. Now we're at subtraction. If we subtract 6 from one side, we have to keep it equal and subtract 6 from the other side of the equation. Same thing goes for multiplying by 7. You have to multiply by 7. Put a comma here. Let's say you multiplied one side by the number half. You'd have to also multiply the other side by the number half. And then dividing, say you divided by a decimal, 6 and 1/10. The other side you'd have to divide by 6 and 1/10. Or let's say with a comma you had to divide one side by negative half. Well, then you'd have to divide the other side by negative half. So basically, whatever is done to one side of the equal sign must be done to the other side to keep things equal. That's what's important with the property of equality. You can see it happening in the hanger and tape diagrams. So there are two sides to an equation in a hanger diagram. You have the equal sign right here. You have the left side, x plus 3, and you have the right side, 5. And we've already studied these. We made the hanger of an x and then 3 1s hanging down here. And basically you're taking off, up here it says you're adding 3. And we just learned with the property of equality we could do the opposite. We could subtract 3, or we can add a negative 3 to that. Either way works, and it takes off these 3. Well, if you're doing it to one side, remember, you got to treat the other side equally. We're going to take off 3 from this side. And we showed it like this, crossing them out, basically taking them off. And what was left over? Well, we had 2 1s, and we had only one x. So that x is equal to the 2 1s. So x is equal to 2. So you can see the property of equality happening there in the hanger. Now on the tape, you can't see it right away, but if you would set it up like we learned, from this point all the way to the end of the piece of tape is 5. And if you kind of cocked your head sideways, you could see just about what's happening. It looks like a hanger. See, if you turn your head sideways, you can see the hanger. This would be the equal sign over here. And if you're taking off 3 here, and that's what we were doing, we're taking 3 off of 5. So minus 3 here, minus 3 here. And we were getting 2 left over. And what was left over here when we took off these 3? Just the x. So the x had to be equal to the 2. X is 2. Here's a hanger diagram with multiplication. We looked at these two. We have 3 x's hanging from the left side and the 9 hanging on the right side. And what splits the equation? The equal sign. Right? And so what do? Well, we can see that between the 3 and the x means to multiply. And to undo that multiplication, we're going to have to take this 3 away on this side. So if we're going to divide this side by 3, let's circle all these, divide by 3, then we're going to probably have to divide this side by 3 as well. And 9 divided by 3 is 3, and 3x's divided by 3 is only 1x. And you can see the answer is x is 3. It's the same problem, so we build it just like we did before on the last tape. It's equal to 9. Here's our equal sign. Here's our 3x's built down here. All right, so if we need to split this up into 3 portions to find out what 1 is, then we're going to divide this by 3 as well as dividing these 3x's by 3. And it gives us x. And this one up here gives us 3. So x is 3. Now the tape diagrams can be a little bit interesting when you're working with the property of equality. You can't quite see it, but it does happen. The hanger diagrams, on the other hand, really show it. So let's get down here and start looking at what inverse operations are. That's a part of the essential question. What are they? What are they used for? So there are steps to solve one-step equations. Now one-step equations are directly from 6th grade. And we're going to do a reminder here because we're also adding decimals in. We're also adding positives and negatives in. So this is a refresher, and maybe you'll be seeing this for the first time. All right, there are a total of 4 steps. The first one, numbered, number 1, you're supposed to locate the variable. So we have 2 examples here for you, and they're laid out. X plus negative 3 is equal to 7, and the variable is right here. It's always the letter. In this equation, we also have it equaling 7, and that would be the equal sign right here. Okay, so that's showing there's 2 sides to the equation. So what is happening to the x? Well, we'll see in a little bit. On this other example, you can see that the variable is right here, right against the negative 3, which means multiplication. And the equal sign is right there. So there are 2 sides to that equation. Let's move on to number 2. Number 2, determine what operation, the operations, there are 4 of them, there's adding, subtracting, multiplying, and dividing, is on the variable side. Now that's important. We want to look what's on the variable side. So there's only 2 sides to the equation, and the side with the variable is the side that has the variable. So there's that one and this one. They could be on the left, they could be on the right. So for our first example up here, determine what operation is happening on the variable side. Well, we can see that we have addition. That's what's happening right there. We're adding a negative. On the right side, what's happening here? Well, this x has a coefficient in front of the x with no operation sign. So right here between these two means to multiply. So squeeze that in. That's what's happening there on that side. So the left one was addition. The right one is multiplication. Moving on to number 3. Use inverse operations, here it comes, on both sides, the property of equality, what we learned in the beginning, of the equal sign to solve. Inverse means to do the opposite of. Kind of like the reverse. Inverse operations, as you know, there are 4 of them. So the inverse addition with subtraction. We inverse subtraction with addition. We inverse multiplication, of course, with division. And we inverse division with multiplication. And then finally, the last step, it's important. Sometimes it's skipped. Check your solution to see if you are correct. And we're going to be using the substitution property, another property. So we've got a lot of properties we're using today. We're using the property of equality. We're using inverse operational properties of both addition and multiplication. And we're using the substitution property. All right. Before we get into the we-dos, let's do a would you rather. All right, backing up to our events up here, we know that there are two sides to an equation. So I'm going to take my highlighter in green and I'm going to highlight the equal sign. And that's just going to tell me that there are two sides. Okay? Then I will locate the variable, and my variable is right here, y. And then I'm going to say what's happening to it. Well, we are adding 4. So we're adding a positive 4. So one thing I can do the inverse of adding a positive 4, and just like way up here, I could add a negative, this says -5, or add -5. That would be the opposite. Whoa, hold on. Just messed that up. So adding the opposite of a positive 4 would be adding a -4. So if I do it to one side, I do it to the other. Draw my line. And you can see right here what happens to these numbers. 4 plus -4 is 0. It's gone, so y is left by itself. And that's exactly what we want. Bring down the equal sign. And -4 plus, or sorry, -8 plus -4, remember the old t-charts. You can use those. Those are both negatives. They both go on the negative side. We find out how many negatives we have altogether, and we have 12 of them. So y is -12. Okay, you could do it that way. Or with the same exact problem, you could locate your variable, or sorry, know where the equal sign is, then locate the variable and see that it is adding 4, and the inverse of adding 4 is subtracting 4. So we could subtract 4 and subtract 4. This is 4 minus 4 would be 0, and y would be left by itself. And -8 minus 4, that looks a little bit stranger, but you could end up using the additive inverse right here. And -8 plus -4 is -12. That's another way to take care of it. So what would you rather do? Would you add, like adding the -4 to both sides, or would you like subtracting 4? Either way gets you the same answer, so you have to kind of choose what you want to do, this way or this way. Same thing with multiplication or division, you have choices. So we want to know where the equal sign is at all times. Here it is, and here it is. And then we want to know where our variable is, and it's z right here attached to the -7, which makes -7 a coefficient. Here it is again. Now the -7 is multiplying the z, so naturally you probably think that the inverse operation of multiplication is to divide. And so we're going to divide not just by 7, but we also need to divide by the negative. And the reason being is a negative divided by a negative leaves the z positive. Okay, what happens when you do -7 divided by -7? Well, any number divided by itself is the number 1. So 1 comes down, the z comes down, and that is equal to, well, the property of equality says if we divide one side by -7, we have to divide the other side by -7. Now this is a positive divided by a negative, and so we know our answer is negative. And 7 goes into 91. Well, that's 91 divided by 7. calculator would be super helpful here. It's going to be negative 13. Now it doesn't look done because we have a coefficient of 1 in front of z, but we know that 1 times z, or 1 times anything, is itself. So z will not be changed by multiplying by 1, so z is negative 13. All right, so we have a would you rather. You could do it this way, divide both sides by negative 7 when you see multiplication, or you could make this negative 7 into a fraction. That's negative 7 over 1, same value. And you could multiply, on this side we divided, we could multiply by its reciprocal. Now that's definitely from 6th grade. If you do it to one side, you have to do it to the other side. And what happens over here? Well, if you take a look, if you do this problem, multiply straight across, 1 times negative 7 is negative 7, and negative 7 times 1 is also negative 7. The z comes down. Over on this side, we can make our 91 into a fraction, and 91 times 1 is 91, and 1 times negative 7 is negative 7. Now, doesn't that look real familiar? Right over here. Okay, what is negative 7 divided by negative 7? It is 1, and 1 times z, we already know, is z by itself. 91 divided by negative 7 is a negative 13. Okay, so that's another would you rather. Would you rather do it this way or this way? All right, turn your paper over, and now it is time to get into it to make sure you know how to do these. There's a lot of them, so it's a lot of practice, which you need. All right, let's go ahead and start in the margin. It says missing coefficients. Highlight that. It's a little extra here that you need. Okay, when you see just a variable by itself, there is a missing coefficient. Remember, coefficients are attached to the variable with no sign between. So how many x's you see there? Only one. So if you put a 1 in front of that x, it means the same thing. So what's right in front of this x that you can't see? You can multiply it by 1 and it does not change its value. This one's negative x, you guessed it. You can just write negative 1x, means the exact same thing, or you can just place a 1 right there in front of it. This one is x divided by 2, or x over 2, a fraction, and there is a 1 right in front of it, so you can write it as 1x over 2. Now it looks like half over 2, and that actually can be written as half x. All those are this very same number, so there's a 1 right here. This is the same number, but the negative version, so we could rewrite it as a 1 in front of the x over 2, and that looks like negative half x, and it is. So we could put a 1 in front of that. So when there's a missing coefficient, you can put a 1 in front of it, and it won't harm anything because it is the identity property of multiplication. All right, so you're going to be using that missing coefficient when you need it. Right here, you don't really need it. X, what's happening to it? It's being multiplied by negative 3. And so remember, would you rather? Okay, you can make this into a fraction, but I, because it's multiplication, am going to divide by negative 3. If I do it to one side, I have to definitely do it to the other side of the equal sign. So divide this side by negative 3, the property of equality. Okay, and we have x is 7 divided by negative 3 is just that, negative 7/3. That's it. We don't change it into a decimal, we just leave it as a fraction in lowest simplification terms. All right, let's look at B now. B, we have an equal sign, there it is, and we have our variable right here. And what's happening to the variable on the variable side? Well, we are adding 7 to it. What's the inverse of adding 7? Well, you might say you could add a negative 7 to both sides. Or there's another way. You could also subtract 7 from both sides. Now it's a little confusing, so I'm going to stick with the first way on this one. 7 plus negative 7 is 0, and n is by itself. And negative 12 plus negative 7 is negative 19. Remember, use your t-charts to get it straight. Let's take a look at C. Here is our variable. It's attached to 3 and 1/10. That's a coefficient. And we need to know where our equal sign is. It's right here. So it's multiplication, so we're going to use division. We'll divide this side by 3 and 1/10. And we'll divide this side by 3 and 1/10. Now we did not use a negative down here. Don't get confused with adding, subtracting. With multiplying and dividing, we match it because we want to leave our variable positive. So a positive divided by a positive is a positive sign. So this right here is going to be the number 1, and 1 times c is just c. On the other side, we're going to have to divide, and that one is going to definitely be using a calculator. My calculator says 2 5/10. On D, this is different. We do have an equal sign, and we also have two variables, E and E. Now, in previous lessons, we learned that on one side of the equal sign, we could simplify, and we need to. These are both E terms, and so we can combine like terms. Negative 3E plus 2E is negative 1E, and that's equal to 35. Now we have this negative 1 coefficient out here, and we need to get rid of it. So the only way to do that, this is multiplication. So we're going to divide by negative 1. And remember, whatever we do to one side, we do to the other. So the reason why we're dividing by a negative is because the number is negative, because the negative divided by a negative leaves the E as a positive. And 35 positive divided by a negative is negative 35. Okay, moving on to E. This is a subtraction sign. And so you could do it a bunch of different ways. But first, let's make sure we know where the equal sign is and where the variable is. Right here. So what's happening to that variable? We are subtracting 1 7/10. So we could easily just add 1 7/10 to both sides. If you didn't like doing that, you could also take that subtraction sign and do the additive inverse. And you can see that we're adding a negative 1 7/10. And to undo that, we can add a positive 1 7/10. See how it works either way? Okay, on this one, this is 3. There's no decimal point, so you know the decimal point's behind it. And you add your 0. This is going to be 0 right here, so x is left alone. And x is equal to 4 7/10. Now we see that the variable is shifting to the right side of the equation. That's fine. There's still an equal sign, and so we see subtracting a negative. Those are hard to do, so we use the additive, and the inverse of negative 2 is positive 2. Now that's pretty easy, n plus 2. So you have choices here. You could either subtract 2 from this side and subtract 2 from this side. Let's do that. This is going to be a 0, and n will be left by itself, and 6 minus 2 is 4. So we turn the answer around, n is 4. Or, instead of subtracting both sides, you could have added by a negative 2 on both sides. So 2 plus negative 2 is still 0, gives you n, and 6 plus negative 2 is also 4. You just turn around, n is 4. Okay, we've got 3 left on the we-dos, and then you're going to start doing them on your own. So this one right here, you can see that we have an x on top, but there's nothing next to it. And we learned about our missing coefficients. So what can we add in front of that x that we can't see? A 1. Now it looks like the number 1/4. Okay? So a good way to deal with this is first knowing where the equal sign is. Second, knowing where our variable is. Okay? And now we need to get rid of the 1 and the 4. A really good way to do this is to multiply by its reciprocal. We did that on the first page. We'll do it again here. So if we're going to multiply this side by 4 over 1, we're going to multiply this side by 4 over 1. We'll make our -3 into a fraction by putting a 1 underneath it. And what happens on the right side? Well, we can cross reduce. All of that stuff is going to give you just the x by itself. And 4 times -3 is -12 over 1. And of course, that is just -12. So we turn our answer around, x equals -12. Okay, this next one, we have our variable, e. There's nothing in between, so we know it's multiplication. And we also know where our equal sign is. So we need to get rid of this -3/4. Now there's two ways to do this. You can divide by -3/4 on both sides, or you can multiply by its reciprocal. So that's what I'm going to do. I'm going to multiply by 4 over 3. Why did I choose 4 over 3? Well, if you multiply straight across, 4 times 3 is 12, 3 times 4 is 12. A negative divided by a negative times a negative is a positive, and so you can see it's positive 12 over 12, which is 1. Perfect. So that's E. So if I multiply this side by -4/3, I have to multiply this side by -4/3. Change my 6 into a fraction, and E is, I can cross reduce there. I hope you learned this in elementary school. 3 goes into 3 once, 3 goes into 6 twice. If you did not learn how to do that, that's okay. Multiply straight across. So 2 times -4 is -8. 1 times 1 is 1, and E is -8. And the last one, I, it looks like it's already solved, but you cannot have a solution with a negative variable. So we learned over here in our missing coefficients, there is a 1 right here. That 1 is doing what to the variable? It is multiplying. So the inverse of multiplication can be division. And x is -28. All right, that's a lot of examples that you may want to rewind and take a look at as you are doing the UDOs. Okay, we have a total of 12 of them before we get down to the test readiness check. So in these 12, we got to make sure you have it down. All right, so I'd like you to pause the video and try J, just J. Pause now. Okay, the answer is 11. So did you see that on J, the variable is in, we have an equal sign, and we're adding a -14, so the inverse of adding a -14 would be adding a 14 to both sides. And -3 plus 14, I use a t-chart, and I got +11. Now we know 11 is correct because we can use the substitution property. We haven't done that yet. We're claiming that n is exactly the number 11. So if we just exchange the n right here for 11, 11 plus -14, well, let me try that again. Let's try it again, -14. Well, if you add those together, you do get -3, so it is a true statement. Okay, pause the video and try K now. Okay, A is negative 84. How do we know that we got it right? Well, we can use the substitution property. Here we go. We're claiming that A is the exact same thing as negative 84, and all you have to do is put negative 84 right where the A is. So if you do that, negative 84, it says, divided by 7 is equal to negative 12. Well, if you put negative 84 divided by 7, you know it's a negative because a negative divided by a positive is a negative. And in your calculator, you're going to get 12. So you can see that you got it right. Okay, pause the video and try the next one, L. Pause now. All right, the answer is A is negative 41. All right, so I located my variable and I found my equal sign just as we've been doing all along. I see that what we're doing to A is we're adding a 3, and so we need to undo that by subtracting 3. Now you can subtract 3 on both sides, but you saw what I did on the other side. After I subtracted 3, I did the additive inverse. So negative 38 plus negative 3 in my t-chart is 41. So my answer is negative 41 because we landed on the negative side. Now you could have, instead of subtracting 3 from both sides, you could have just done the opposite, adding a negative 3 to both sides. And you see they look the same as well. All right, so I'm going to have you guys pause the video and you're going to try this complete row right here. M, N, and O. Pause the video and try all of those right now. Here are the three. On M, we had D is equal to negative 1 and 8/10. N is G is equal to negative 20, and O is H is equal to negative 3. So if you got all of those right, you are in the right spot for this math. That's a good thing. If you didn't, look to see what you're getting wrong and ask your teacher a question or ask someone something quickly so you can make sure you can correct your mistakes and get these right. Now, if you've just been moving through the video like some people do and just write down all the work and all you're doing is copying, well, then you probably don't know how to do this on the test, and that's going to be pretty miserable. So if you are one of those students that just tends to copy and write these things down without really knowing how to do it, you probably need to rewind this video and start again for your own sake. All right, let's take a look at the next row, P, Q, and R. Pause the video and do all P, Q, and R. Pause now. Okay, hopefully you had more success or even better success, or you maybe finally got what we're doing here. So P is X is 5, Q is R is 2 and 8/10, and R is negative 17. Or sorry, T is equal to negative 17. All right, on S, T, and U, these are your last U-dos. Pause the video and try those now. Okay, you're back. We see that S has an answer of Y is equal to 30, T has an answer of W is equal to negative 18, and U is X equal to negative 45. So take a look at the details. What we're doing here, we learned about the property of equality. Whatever you do to one side, you do to the other. Treat things equally on both sides. So there are two sides, and we highlighted those sides in green all the way through our notes. Okay, there are other techniques to do as well. So if you see a simple problem as x plus 1 is equal to 2, you could highlight the equal sign. You can leave nothing. You could do nothing and just know there are two sides, or you can even draw a wall. So you can know that there are two sides to that equal sign. So there are just different methods so you don't get confused. Then you'll use the inverse operations. You'll locate the variable like we did. You got the x right here, and then you'll see what's happening to it. Well, we're adding a 1. So what's the inverse of that? That is subtracting 1 was an option, or adding a negative 1 was another option. So you had option 1 and you had option 2. That was the would you rather on the first page. Now, the property of equality says if you subtract one side by 1, you have to subtract the other side by 1. If you add a negative 1 to one side, you have to add a negative 1 to the other side. Okay? So this is the property of equality, and this is the property of equality. So either way, you got to choose one, and then you'll find out x is 1. All right, so now we're down to the test readiness section. So some of these are review. So if you don't feel confident, you could go back and look in your notes. So V, right here, that's back in the expression days when we were doing something that's called simplifying, and this was something going on here with, I won't give it away. Factoring was a few lessons ago. To evaluate, that was another couple lessons ago. And on this factor one, there's also additional question here. After you factor it, you want to give what the GCF is. After you do VWX, y is into the value of p, so that the expression 12 plus 5h is equivalent to p times 4 plus 2 and 5/10 h. And then z into the value of t when the expression 40s plus t is equivalent to 8 times 5s minus 2. So all of these are review. They come from past lessons. So you could look back in your notes to help you with these. Pause the video as you try to do the test readiness check. Pause now. Okay, here are the answers. We did have a problem with y, and so we're going to talk about that in a little bit. But v works out as negative 12k plus 4/10. W worked out the upside down cake method. I took out a 2 first and then a 3. If I had saw that I could take out a 6, it would have been shorter for me. So 2 times 3 is my GCF of 6. And x, there's that 1 right here, that missing coefficient. So I added a 1, and then I distribute the negative 1 to the negative 7 and the 3, and I got 7s plus negative 3, and I know that I can write it cleaner with less signs. 7s minus 3 means the same, and I can prove it by using the additive inverse here, and look, it looks identical. So I take those two off, and that's the same. Now let's talk about y. Now as I started working on y, I wrote it this way and I saw an error, and I don't think it's possible to figure it out the way I had it. I had a 4 here, and the way that would work to make this 12 come true, that 4 would have to be a 3, so that p would be a 3. Now when you take that 3 and you times it by 2 and 5/10 h, you don't get 5h. And so there was a big problem with this one. So if you change the 4 to a 6, let's work through this together. Erase your work if you had work here. Change the 4 to 6, or do your work right over here. We would go through this one, okay? What times 6 is 12? Well, 2. So you think it's 2. Okay? So we'll try it out. Okay, 2 times 6 is 12. That works. We got a 12. Plus 2 times 2 and 5/10 h is actually 5h. And that's what we need there. So you can see that our p that we're missing here is a 2. We need a 2 out in the front. So p is 2. Now the way I had it written as with a 4 there, I don't think it's even possible to get a solution. So I do apologize for having the wrong number. So hopefully you caught that before you started working on it. And then finally, z into the value of t when the expression 40s plus t is equivalent to 8 times the difference of 5s and 2. So I used my additive inverse over here, and I did my distributive property, and I got 40s plus negative 16. I lined up my answer with the simplified version. 40s is 40s, the plus sign is the plus sign. And so that means the t is the negative 16. So t is negative 16. Now remember, in all notes, you can always review these. Ask your teacher questions to make sure that you have this lesson down.